Everyone, welcome to Learning by Doing with Praveen Kandan. This is Praveen. In this Java object-oriented programming playlist, you will learn OOPS concepts from the scratch. This is Java OOPS programming session number 67, Downcasting concept. If you're serious about learning, then like the video and subscribe the channel for more update. Please click the bell icon and select all notification option. Don't choose personalized option. You may miss some session updates. Let's get started, guys. In our previous session, we have discussed about upcasting in a detail manner. Now, jump to the downcasting concept. So, downcasting means converting a parent reference back into its child type. So far, the parent reference referring to the child class object or child object is stored in the parent class reference. This is what we discussed. Now, one step again. So, we are converting the parent reference back into its child type. So now parent reference is converted into a child type. Okay. See here, the line number one you can able to easily understand. This is called upcasting. Parent reference referring to the child object. This is what implicitly what will happen. I told you the child class object will be stored in the parent class reference. Next, downcasting means what we already mentioned, clearly explained about that parent reference back into its child type. That is promotion, typecasting. We are backing that. Okay, parent reference into child types. A is the parent reference type. Now I'm converting. Now we are converting some type like integer to float or something we are doing. Am I right? Type conversion, converting from one type to another type. Now what I'm doing means converting this parent reference back to the child type. So which type is required means that type you have to give that parenthesis. That type which the type you require. So give that type in the parenthesis. Okay. Give this required type in the parenthesis. What is that required type is here? Dom. So converting the parent class reference into child class reference, that is child class reference type inside this parenthesis. This is the important. This is called as a downcasting process. That's why I'm explaining three times again and again. Important step. This is called as a downcasting. This line is called as a upcasting. Next, you can now directly access d dot park means usually what will do a dot park will give this time d dot park because we already converted typecaster to downcast. So child class object type will now directly access it. So first we'll discuss for context upcasting we'll discuss now. So compile time will check. What will check? So animal class reference type is present or not. Java says animal A and new dog. Upcasting is implicitly happen. Runtime check. What will happen? JVM stores a dog object in our memory reference as type animal. So it is a safer one. Because at runtime it is going to execute this method. Downcasting means during compilation time what will happen means allow this because you explicitly cast A to dog. What I told you, internally it will store the parent class reference stores the child class object. Here explicitly we are doing allows this because explicitly cast A to dog. A is a parent class reference, now it is converted into child class. At compile time, it does not check the actual object type. Important thing, it will not check the actual object type. It only check that A is a super class reference or not. Important thing, see here. It does not check the actual object type. Okay, what is that actual object type means? This new dog will not be checked. What important thing? Kindly make a note of it. At compile time, it does not check the actual object type. Dog means whether it is object created or not. It will not check. Okay, all right. It will only check that is a super class reference. A is a super class reference that can potentially be a dog. This is what it will check. Super class reference animal. Whether this A is coming under the animal class reference or not. Yes. So then it can be potential be a dog. So now it is possible to convert into a dog because downcasting what's the procedure? So if you are converting into a child class object, first it should be a parent class. Then only it should be converted into down. What is a child class? That is why that process called as downcasting. That's what it is here also checking that A is first of all a animal class reference, that is parent class reference or not. Then it can be potentially be a dog. Runtime JVM checks the actual object in memory. So whether it is already created or not. So after created, is the job reference this the object referenced by really a dog? Is the object referenced really a dog? Now only it will check. Okay. So is this of what is the reference a really a dog? How it will check? Is the object referenced by a really a or dog? Yes. How it means D now refers the dog object because what we are doing converting into dog. Now only it will check. Okay, is the object referenced by a really dog? Yes, because we already created a new object dog, so it is possible now. So cast succeeds. D now refers the dog object. D now refers the dog object. Okay. Accessing child method d dot bark means compiler see d is of type dog or not, whether this method is coming in the dog class or not. So it allows calling bark. Runtime, it will execute the actual bark method. Here runtime only already told you many number of times. Runtime only the method will be executed. Compile time it will check, see whether it is a type of dog or not. So this is what happening. Compile time check dog d equal to means check cast is syntactically allowed or not, or correct or not. As per the syntax, it is right. The promotion type should be present. Reference parent class reference variable should present. Yes, it is present. Runtime check what will happen. Check object is actually a dog. First of all, this dog is actually a dog or not. That is a runtime object or not. Runtime, that is a child class or not. Check object is actually a dog. After the d dot method is compile time, will check method exists in dog or not. That the method is exist in dog or not. When it will be executed means at runtime only it will be executed. Key rule is downcasting is safe only when the object was originally created as a child class. Only when the object is created as a child class. If you try here, this line is called as a equal to new animal means. Okay. Here we are simply just like that doing. Okay, compile time. It is not a upcasting, just creating the object. If you are doing this dog of a class cast exception runtime, because here if you are giving the dog, actually dog object is not already present. You have created object for animal. Am I right? You have created the object for animal, but someone is coming here. It looks like dog means they don't know who is dog here. As per the definition, it is wrong. Am I right? It should be the child class. You already know. I already clearly mentioned here runtime. It will checks actual object in the memory or not. Whether the actual object is present in the memory here? No. Because animal object only is present in the memory. Dog object is not created. It is not allowed. So compile time itself will get an error. It is not allowed. Okay. So is it right? Compile time will check? No. Read it carefully. Compile time as per the syntax is right. That's why I voluntarily did the mistake. Because compile time it will be allowed. I'll get into the code, you can clearly understand. Instead of telling the theoretical manner, I'll get into this code where is animal is there. I'll cut remaining things under. See here, this is what usually will do. Upcasting is possible equal to new. What is the child class name? Dog. Okay. So now you can call this a dot what method they are using. I think play. Definitely it is possible. Compile time will check the reference types alone, and then this method is present in the animal class or not. Yes, present. Runtime only at the time of object creation. Okay, after creating object creation, with this method, which method? Dog class method will be executed. What is that? Play with dog. Playing with dog will be executed. Yes, obviously playing with the dog will be printed. So 1 minute I'll run the one more time because it is executing the previous code. So now we are just calling dog class and playing dog. So if I'm doing the downcasting animal or dog, whatever it is. So here we should use as a downcasting anim dog only. Okay, upcasting is done. Dog as per the syntax. So reference type equal to here, yeah, within the inside that is inside this parenthesis you have to give the child class type name. What is that? Dog. Child class name I'm giving as per the syntax. After that, nearby what I'm doing. So which class is reference? I mean, which class reference converted into a parent class? Sorry, that is which class? Which parent class reference is converted into a child class? Means animal A. So A is present. Here there is no issues. Here, no error. Yes, downcasting means we are read out carefully. We already clearly mentioned that converting a reference back to its child type. Converting parent reference which one? Parent reference is animal A. So this A is converted back to the child class. This is what we are trying now. So at compile time syntactically correct because inside this parenthesis you have to give the runtime. That is a what is that? Sir? Not runtime. That is a child class name. Dog. Yes, it is present. Compile time no issues. If I'm exiting runtime, check it out. Class cost runtime exception throw. If our concept is right, it show the message. Once again, I'll save it and run it. It exiting the previous code. Should throw an error. Wait, what is happening here? New dog of A. Yes, actually we already executing this. Already the child class is present. Am I right? We already mentioned that it will check during the compile time. Step one, what is that? So upcasting is done. Second step is downcasting is also done. So everything will work. Am I right? During compile time, explicitly you are giving the cast dog A. Okay. Compiler allows this because we explicitly cast it. So at compile time does not check the actual object type. So this portion will not really executed at the time of compilation time. It will check only whether this A is already present in this parent class reference or not. Yes, this is what will check. It won't check this new dog and all because at runtime it will runtime only it will check. So during compilation time, whether this animal class A is present or not. Runtime only it will create the object. So because of this object hereafter, this object A dot play means this dog class play method will have. Okay, should be clear with this. So I'm giving this line after this. Okay, this was the important procedure here. I'm using the D dot play. Mark my word, important. So far there is no compilation error because we already no compilation error, no runtime error also. We have already done the upcasting process and then converted it downcasting. It will execute. If I'm executing this, 100% perfectly it will work. No issues. 100% the code will work. Reason, everything is fine. Upcasting is done, downcasting is done. This method is also present. But if I am not giving this animal class, I'm commenting this. Now see here, dog d of this problem only, this mistake only now you are voluntarily doing. What you are doing means new animal. Okay, so you are creating the object, but not for dog, for animal. See here, no compilation error. Important derivation, no compilation error. Compile time or syntactically correct because syntactically inside this parenthesis you have to give the child class object class name, and then right side you have to give the parent class reference type name. It is good, but runtime what will check during compilation time? It will check the class references person. After this, as per the syntax, this reference type should be present. There is child class, reference class name should present. Here, parent class reference name should present. That's it. This is what it will check. It won't check whether this object first of all created for this dog or not. Whether object is created for this dog class or not. It won't check. So runtime we will expect the exception class cost exception. Class cost exception, because many of the beginners are confused with that. So class cast custom exception is now coming, because there is no object created for the dog. Then how we can create a dog class, and then you'll give the promotion type as from parent class to child class? How you will create it? First of all, it should be the object. Then only it is possible to convert into a dog reference type. This is what they're telling. Downcasting safe only when the object was originally created as the child class. But here there is no child class object itself. Then how we can convert into a child class reference? So it is not possible. JVM says A is not actually a dog. A is not actually dog. If it is actually dog means you have to give this line, because here dog class is already created, so is a relationship is followed. So dog is a animal. So this dog class have the ability to store this A. See here, this dog class is now is here following this relationship concept. So dog is a animal. So object is present. So now it is possible to convert this parent class reference to child class. So I'll show the diagram flow. You can easily understand. Compile time. It will compile as is animal. This is what internally happened. It will check animal A equal to dog. I will tell you know, so new dog will not be exit compile time. So animal A equal to dog means animal, first of all it check whether the class reference is, that is a parent class reference is present or not. Oh yes, good. Next, compiler is dog D equal to dog of A. It will check as per the syntax it is correct or not. Yes, cast wise inside the parenthesis child class name should present. D dot bark means compiler is whether this bark method is present in the dog class or not. Yes. So D dot play here I'm missing. So D dot play means this play method is present in this dog or not. This is what it will check. During runtime only, JVM creates a dog object in the memory. New dog of if you're giving, so it will create the object. So, yeah, where it is here. So new dog it means, so now only this object is created in the memory. So JVMC's actual object is dog or not. So actual object is dog or means yes, actual object is what is that new dog. Okay. Yes, it is a dog. So JVM check is a really a dog. Is a really a dog. Is what will check. A really a dog. So really a dog means what will happen sometime object type equal to dog or not. Object type equal to dog or not. Yes, object type is dog only. This is what I will check here. Because you are checking is A really a dog? Is A really a dog or not? That's what you are checking. So for that purpose, what will happen means object type equal to dog. Object type is which one? Dog. So now cast succeeds, it will be converted. In case if it is not present, what will happen? So I will comment this line number 7. So during compilation, no issues. Runtime, it will create a object for which one? New animal class. It will check is A really a dog or not. So it will check how means this runtime check. Okay, dog is here object type or not? No. Dog is there is no object created for this dog in the memory. So cast failed. Okay, no exception. Class cast exception will be thrown. So JVM executes bark method if it is true only. Okay, runtime method. If it is runtime is yes, cast succeeds. Otherwise, don't execute. So key takeaways: upcasting here, compile time automatic save. Compile time itself will check the reference is not marked. But runtime object stored as dog reference is animal. Downcasting allowed if syntax is correct explicitly. JVM checks actual object type. Save only if originally a dog. Child method compile time, it will method exist in dog or not, it will check, it won't execute. Runtime only, it will be executed. This is the diagrammatic representation. Compile time, animal A equal dog. Yes, animal is a class reference. Done. So here, what is that cast? So as per the syntax, cast is correct or not. Inside the parenthesis, you have to give the child class constraint. Done. B dot mark, bark method means this bark existing dog will execute. At compile time, it will just ensure that exists or not. Bark method is present in the dog class. At runtime only, dog object is created. Actually, object is here dog. Yes, it will check. Actually, object is here dog. Yes, is yeah really a dog. It will check. So yes, then only cast succeeds. Otherwise, it will throw the class cast exception. If it is executing, it will override the existing bark method in the base class animal. Now it is executing the dog class run time at the runtime. Dog class bark method will be executed. Which dog is compatible with animal means inheritance relationship is following because we are extending the animal. So dog is a subclass of animal. So in Java, every dog is an animal. So this is called as this relationship. Assignment rules in Java. You can assign an object of a subclass to a variable of its superclass. This is what happening. So assigning object of a subclass to a variable of its superclass. Compare is whether dog is an animal. Yes, assignment is legal. So when you do animal equal new dog, Java is upcasting automatically. So parent class reference referring to the child class object or child class object stored in the parent class reference. Upcasting always works and self because subclass object contains everything the superclass expects. So superclass expects only the child. So everything is here available. Think a real-time example. Animal as a vehicle, dog as a car. What will happen? Completely controversy. Every car is a vehicle. Am I right? Every car is a vehicle. So you can store car in a variable of type vehicle. Vehicle, new car means yes, every car is a vehicle. But now, not every vehicle is a car. If you are giving in a reverse direction, not every vehicle is a car. So not safe. This is exactly why downcasting needs explicit check. You have to check it out. For that purpose only, you are giving that in the inside test parenthesis. Okay. I hope you are clear with this. So at that time, these problems can be avoided. So during that check, it will be find out whether it is a type of the parent reference is type of the child class or not. So the simple key rule is a subclass object is always compatible with superclass, right? But a superclass object is not automatically compatible with the subclass. We have to do the alterations. We have to typecast it. The final comparison table, upcasting means direction. Okay. So child class is stored in the parent class object. So cast is implicit, but it is safety one. Polymorphism is properly achieved. Downcasting, we are we are converting the parent class reference into a child. Explicitly, we are doing the typecast. Safety is risky one because just like that, anyone can able to typecast it. So child methods will be executed directly. I hope you clear this decision. Even though the video size is too large, concept understanding is very important. If you found the session useful, then like the video and subscribe the channel for more updates. Please share it with your friends. Thank you for watching.